sulfur hydroxy. Sulfur hydroxy. So what are the examples of the sulfur hydroxy? One of the amino acids, CH2, then go here on the top, you have SH. What is this guy named? Cysteine. This is a amino acid has a sulfur bouncer. Okay, so that's sulfur hydroxy. So these are the major biological chemical groups we introduced to you. What's the timeline I need to see? 25. I have another class started at 2 o'clock, which is for general microbiology, a general education class. So all the time, we will be finished around 1:35. Because I need to take a break and then go for another class. Okay, so this is a major biological function chemical groups. Okay, then we're gonna talk about syllabi today. We haven't talked about what we're gonna teach in the semester. We mentioned all these basic knowledges. What we want to talk about in this semester, major outline, is what I always cover, is we will talk about water and ice in the first couple of lectures. And after that, we have a little bit of small section, and Ian will tell us how to use pH meter to measuring pH, how to use water activity meter to measuring water activity, and also the moisture measurements. We're going to mention about that. It is, you think it is easy, but when you go to the lab, you always made a mistake. Especially measuring the pH, it is important for the chemistry, and also important for microbiology, because that's a major standards for bacterial growth. Okay, so remember, another major research direction is for the microbiology, so we want to emphasize that in the lab. So the first one we want to talk about is water and ice. Then we will talk about is a protein. The protein section, we basically talk about amino acid structure. Then Dr. Brett Kinney will have a guest speaker guest lecture talk about muscle foods. Then we will spend in one class talk about the Maillard reaction. That's important for the non-enzymatic browning. Then we talk about something else, especially the meat tenderization. Meat tenderization in this Phenom food chemistry is at the end. It's very heavy, about like 20 pages talk about that. But we will be relatively briefly mentioned, but it is important. Then we will talk about the lipid section. Lipid section, we go through basic knowledge, then we will go to auto-oxidation, which is we call it a general rancidity. That's a key of that section. And then we will move on to carbohydrate, which means sugar. Here we will talk, a major part is how they manufacture table sugar. Then we will talk about from beets and how they manufacture it. Then we will have a fermentation section. Because fermentation originally should teach in microbiology parts, we didn't mention that. Fermentation part, we will talk about the beer brewing and the wine manufacturing, and very important is the vinegar manufacturing, because that's a double secondary fermentation. So we will talk about the fermentation section. Then we will talk about the antimicrobials, because it's a chemicals. We'll talk about it from the chemical standpoints. Okay, so this is basically the outline, and every topic, especially those 5 sections, we're spending 4 lectures for each of these sections, and as a mix of those books. Okay, so that's outline of what we're going to talk. Last question will let you off today. a very simple question for you. What is 1 mole? If I say we're going to measuring 1 mole sodium hydroxide, what that means? This equals 6.02 multiplied by 1023. What is this called? Avogadro constant. So let's do a very simple math question. If I want to prepare 1 mole sodium hydroxide in 1 liter water, how we should measure how many sodium hydroxide should be there? This is not difficult. We need to find the molecular weight or mass weight of each chemical atoms of sodium hydroxide. That is 23 add 16 add 1. Okay, that equals 40. So 40 gram dissolved in 1 liter water. Now, why I want to mention this one? What kind of the solution will generate if you dissolve 1 mole hydroxide into the water? It's a very alkaline solution. The pH equals 14. Therefore, it comes out to our last warm-up question. What is pH? Can you think about that's a very easy question. What is pH? pH equals negative log 10, the concentration of proton. And the value ranged from 0 to 14. pH 7 is a neutral status. So we already said that pH 14 is 1 mole NaOH dissolved in 1 liter water. What is pH 0? It's not going to be pH 0. How about pH 1? What is pH 1? Which products is pH 1? Very acid. You know, you probably not recognize it. It's battery acid. That's why all the old battery has to be recycled. You cannot just throw away in the trash can because it's very acid, okay? Very corrosive, in other words. How about our stomach acids? Our stomach is the first defense of the pathogen. So it's very acid. The pH is about 1 to 2. Now, obviously, you know, like a lemon juice, the pH is about 3 to 4. How about pH 7? In our real life, actually, it's very difficult to reach pH 7 unless you make phosphate buffering solution. Now, our drinking water, if the distilled water or tap water, if you find, you can measure it. The tap water in our building, the pH is about 5 to 6. Okay? Go this way. I want to mention one thing. It's about the pH 10 to 12. What is that? Chlorine solution. Chlorx. This is something we also will be mentioned in the water section. If you buy a bucket of Chlorx, the pH is 10 to 12, which means the major components is not hypochloric acids. That means if you buy a bucket of chlorine, you're just dumping somewhere, the ability to killing the bacteria is not going to be very strong. most of the time in the real fresh produce industry, they have to add acid products to low down the pH about 7, because at that moment, the dominant component is hypochloric acids. Now, in our microbiology area, we had some chemicals could be showing the indication of the different pH level. We call it a pH indicator. Let's say the common one we're using is phenol red. And this phenol red is very yellow color at lower pH, and it is cherry red color at alkaline solution. In the neutral, usually it's a little bit of purple to pink color. Okay, so that's a pH indicator for the phenol red using the bacterial media. So this end up with our first class, give you an introduction of all the chemicals. Most of these are in your slides, and this part we just added there to let you refresh. So we try to catch up with you all this knowledge. And the Thursday we will talk about is a biochemistry reaction. We talk about glycolysis, TCA cycle, substrate level, phosphorylation, oxidative phosphorylation, electron transport chain. If we get the time, we will review DNA and RNA, because in the food chemistry, we don't talk about DNA and RNA. However, it is important. Some content in the textbook will suddenly show up, so we will be review that on Thursday. Okay? So that's all we have.